Namaste, and once again welcome back to another session of online maths class. In this session we are going to discuss miscellaneous exercise on chapter 5 continuity and differentiability of NCERT Class 12 mathematics textbook. So it's the part 1 video. In this video we are going to discuss question number 1 to 12, and in the upcoming videos we shall discuss the remaining questions. Okay, let's start with question number 1. Here the question is, differentiate the following functions with respect to x. And the first question, 3x square minus 9x plus 5 the whole raised to 9. Okay, so this can be taken as y. So let y is equal to 3x square minus 9x plus 5 the whole raised to 9. Clear? Now it is in the form x raised to n. And we know the derivative of x raised to n is n x raised to n minus 1. You have already learned the formula. Derivative of x raised to n is what? N x raised to n minus 1. But in this question, instead of x, the term is 3x square minus 9x plus 5. Okay, so this can be treated as x. Now it is in the form x raised to 9. And the derivative of x raised to 9 is what? 9x raised to 8. N x raised to n minus 1. Okay, we have to write the exponent first, that is 9. Then x raised to 9 minus 1. 9 minus 1 is what? 8. But instead of x, here the term is 3x square minus 9x plus 5. So we can write dy by dx is equal to 9 into 3x square minus 9x plus 5 the whole raised to 8. Clear? Now we have to apply the chain rule, that is into d by dx of 3x square minus 9x plus 5. First we suppose the whole term as x, so that we have to multiply what? The derivative of that particular term, that is derivative of 3x square minus 9x plus 5. Clear? So which is equal to 9 into 3x square minus 9x plus 5 the whole raised to 8 into derivative of 3x square minus 9x plus 5. Derivative of 3x square is 6x and derivative of minus 9x is minus 9. Derivative of 5 is what? 0. 5 is a constant, so its derivative is 0, which is equal to 9 into 3x square minus 9x plus 5 the whole raised to 8 into, here 3 is common, so that we can take it out, 3 into 2x minus 3. Right. Now 9 into 3 is 27, and write this term first, 2x minus 3 into 3x square minus 9x plus 5 the whole raised to 8. So the final answer is, that is dy by dx is equal to 27 into 2x minus 3 into 3x square minus 9x plus 5 the whole raised to 8. Okay. Here the second question is sin cube x plus cos raised to 6x. Okay. So let y is equal to sin cube x plus cos raised to 6x. dy by dx is equal to, let's take the first term, sin cube x. So sin cube x can be written as sin x the whole cube. Sin x the whole cube. So now it is in the form x cube. But instead of x, the term is what? Sin x. So x cube derivative 3x square. So derivative of sin cube can be written as 3 sin square x. So derivative of sin x cube is 3 sin square x, and we have to multiply by the derivative of what? Sin x. That means the chain rule. Okay. So here we can write 3 sin square x into d by dx of sin x. Okay, because we take the term sin x as x. In order to take the derivative, we take sin x as x and apply the formula x raised to n. Derivative of x raised to n is n x raised to n minus 1. That's why we multiply with the derivative of what? Sin x. Then plus in the second term cos raised to 6x, that is 6 into cos raised to 5x n x raised to n minus 1 and derivative of cos x d by dx of what? Cos x. Clear? Which is equal to 3 sin square x into derivative of sin x. Derivative of sin x is cos x. Then plus 6 cos raised to 5x into derivative of cos x and it is minus sin x. Understood? So in both the terms 3 sin x cos x is common, that we can take it out. So this can be written as 3 sin x cos x into, here on sin x remains, so sin x, then here on minus sin, from 6 we take on 3 out, so the remaining is 2, 3 2s are 6. Okay, then cos raised to 5x, on cos x we take it out, so the remaining is cos raised to 4x. The sin x we take it as common. Clear? So the final answer is 3 sin x cos x into sin x minus 2 cos raised to 4x. Clear? Now we move on to the third question. 5x the whole raised to 3 cos 2x. So let it be y, let y equal to 5x the whole raised to 3 cos 2x. Okay, so in this question it's in the form a function raised to another function. That means it's of the form y is equal to some u raised to v, where u and v are functions of x. In this situation we can't find the derivative directly, so we are going to take logarithms on both sides. In the previous topic logarithmic differentiation you have already learned it. Clear? So here I take logarithm on both sides, taking logarithm on both sides. So here log y equal to log 5x the whole raised to 3 cos 2x. Okay, this can be written as log y is equal to, here it is in the form log a raised to b, and we know that it's equal to b log a, the power rule for logarithms. Log a raised to b is equal to b log a. So this can be written as, here the exponent is 3 cos 2x, that we write first 3 cos 2x into log 5x. Okay, now we can differentiate with respect to x. So here in the LHS part it's log y, and derivative of log y is 1 by y into dy by dx, which is equal to, and on the RHS part the terms are 3 cos 2x and log 5x. So the first one you can take it as u and the second one as v. That means it's in product form. Whenever we are dealing with the product of two functions we have to apply the product rule, that is d by dx of uv is equal to uv dash plus vu dash. Okay, that is what is called the product rule. First into derivative of second plus second into derivative of first. Okay, so here 3 cos 2x into derivative of log 5x. Derivative of log x is 1 by x, but instead of x it is 5x, so we can write 1 by 5x. Okay, log x 1 by x, so log 5x 1 by 5x into derivative of 5x. Here instead of x the term is 5x, so we have to apply the chain rule. So derivative of 5x is 5. Okay, then plus second function, that is log 5x into derivative of first term, that is derivative of 3 cos 2x, that is 3 into derivative of cos 2x is minus sin 2x into then derivative of 2x, okay, it is 2. So which is equal to, here we can cancel this 5 and 5 and the remaining is 3 cos 2x divided by x. Then here plus into minus minus, 3 2s are 6, sin 2x, then log 5x. Okay, that is dy by dx is equal to, this y we can multiply, y into 3 cos 2x divided by x, then minus 6 sin 2x into log 5x. Now we can replace the value of y, that is dy by dx is equal to, y means the question itself, that is 5x the whole raised to 3 cos 2x. So 5x the whole raised to 3 cos 2x into this term 3 cos 2x divided by x minus 6 sin 2x into log 5x. So dy by dx is equal to 5x the whole raised to 3 cos 2x into 3 cos 2x divided by x minus 6 sin 2x into log 5x. Understood? Now we move on to question number 4. Sin inverse x root x, and the condition is 0 less than or equal to x less than or is equal to 1. That means x is defined in the closed interval 0 1. Okay, so let it be y, let y is equal to sin inverse x root x. Now we can find the derivative, dy by dx is equal to sin inverse x root x. So this whole term can be treated as x, sin inverse x, and we all know the derivative of sin inverse x is what? 1 by root of 1 minus x square. Okay, the derivative of sin inverse x is 1 by root of 1 minus x square. Here instead of x the term is x root x. So we have to replace this x by x root x. That's all. So 1 by root of 1 minus x square. In the place of x we have to write x root x, the whole square. Okay. Then into derivative of x root x. We assume x root x as x in order to apply the formula. So we have to multiply with the derivative of what? That particular term, that is x root x. Clear? So which is equal to 1 by root of 1 minus x root x the whole square. X root x the whole square means x square into root x square. Root x square is x. Okay, we have to take the square separately. X square, that is x square, and root x square is root x into root x, and it is x. Understood? Then here derivative of x root x. First of all, this x root x can be written as x raised to 1 into x raised to 1 by 2. Root x is x raised to half, so we can write x into x raised to 1 by 2. Now we can combine these two using the result a raised to m into a raised to n is equal to a raised to m plus n. Okay, so here x raised to 1 plus 1 by 2 and it is x raised to 3 by 2. That is x root x is equal to x raised to 3 by 2, and here we are going to find the derivative of this term, that is x raised to 3 by 2, and the derivative of x raised to 3 by 2 is 3 by 2 into x raised to 3 by 2 minus 1. Okay, n x raised to n minus 1. Here we have to find the derivative of x root x, and we write x root x as what? X raised to 3 by 2, then we find the derivative. X root x is x raised to 3 by 2, and the derivative of x raised to 3 by 2 is what? 3 by 2 into x raised to 3 by 2 minus 1. Derivative of x raised to n n x raised to n minus 1. Okay. So which is equal to 1 by root of 1 minus x cube. X square into x is x cube. Then 3 by 2 into x raised to 3 by 2 minus 1. That we can simplify 3 minus 2 by 2. That is 1 by 2. X raised to 1 by 2. So which is equal to this 3 by 2, I write first 3 by 2 into 1 by root of 1 minus x cube into x raised to 1 by 2. X raised to 1 by 2 means root x. Root x in power form we write it as x raised to 1 by 2. So x raised to 1 by 2 can be written as root x. Now I combine these two terms. That is, I am going to write these two terms in one single radical sign. That is 3 by 2 into root of x by 1 minus x cube. We have formula root of a by b is equal to root a divided by root b. In lower classes you have learned that root of a by b is equal to, we can split root a divided by root b. So using this one we can write 3 by 2 into this root x and root 1 minus x cube. I combine and write x by 1 minus x cube. Clear? Now the next question is cos inverse x by 2 divided by root of 2x plus 7 minus 2 less than x less than 2. Okay. So let y is equal to cos inverse x by 2 divided by root of 2x plus 7. And the question is in u by v form, that is quotient form. So we have to apply quotient rule. Derivative of u by v. We know it is v u dash minus u v dash divided by v square. That is denominator into derivative of numerator minus numerator into derivative of denominator divided by square of the denominator. Okay. So here dy by dx is equal to denominator. First we have to write the denominator and it is root of 2x plus 7. Then derivative of numerator, derivative of cos inverse x by 2. Derivative of cos inverse x is what? Minus 1 by root of 1 minus x square. Derivative of cos inverse x is minus 1 by root of 1 minus x square. So here we can write minus 1 by root of 1 minus x by 2 the whole square. Instead of x the term is what? X by 2. So here also we have to write x by 2 the whole square. And we have to multiply with the derivative of x by 2, that is d by dx of x by 2. Once again, denominator into, that is root of 2x plus 7 into derivative of numerator, and in the numerator the term is cos inverse x by 2, and we know the derivative of cos inverse x is what? Minus 1 by root of 1 minus x square, and here minus 1 by root of 1 minus x square. Instead of x it is x by 2, so x by 2 the whole square, and we have to multiply d by dx of x by 2, derivative of x by 2. Then minus uv dash. Uv dash means numerator into, that is cos inverse x by 2 into derivative of denominator, that is derivative of root of 2x plus 7, and we know the derivative of root x is what? 1 by 2 root x. Derivative of root x is 1 by 2 root x. So here we can write 1 by 2 root of 2x plus 7. And again we have to multiply the derivative of 2x plus 7, that is d by dx of 2x plus 7. Clear? Numerator cos inverse x by 2 into derivative of denominator. Here the denominator is root 2x plus 7, that is root x. Root x derivative 1 by 2 root x. So 1 by 2 root of, instead of x the term is 2x plus 7. So we write as it is and multiply the derivative of 2x plus 7. That is we apply the chain rule. Okay. Whole divided by v square. V means the denominator, that is root of 2x plus 7 the whole square. Clear? So which is equal to root of 2x plus 7 into here minus 1 by root of 1 minus here x square by 2 square is 4, then derivative of x by 2 and it is 1 by 2. Derivative of x is 1, so 1 by 2. Then minus cos inverse x by 2 into 1 by 2 root of 2x plus 7, then into derivative of 2x is 2 and derivative of 7 is what? 0. 7 is a constant, so it is 0. Now here we can cancel on 2 and 2, and this much term the whole divided by root of 2x plus 7 the whole square, that means 2x plus 7. Okay, that is dy by dx is equal to root of 2x plus 7 into minus 1 by, here we can cross multiply this one, 4 into 1, that is 4 minus x square divided by 4, root of 4 minus x square whole divided by 4 into 1 by 2, then minus cos inverse x by 2 divided by root of 2x plus 7, then whole divided by 2x plus 7. Okay, which is equal to root of 2x plus 7 into minus 1 by root of 4 minus x square divided by 2. Root of 4 is 2, so we can take the square root into 1 by 2. This 2 and 2 we can cancel, minus cos inverse x by 2 divided by root of 2x plus 7 whole divided by 2x plus 7. Okay, now we can split this denominator, that is this minus I write first, minus of root 2x plus 7 into 1 by root of 4 minus x square whole divided by 2x plus 7. Here also minus cos inverse x by 2 divided by root 2x plus 7, then divided by 2x plus 7, that is 2x plus 7. Okay, so which is equal to this minus sign we can take common, so minus of, in the first term here root 2x plus 7, denominator 2x plus 7. So if we cancel these two, the root sign will come on the denominator, that is root x divided by x, which is equal to what? 1 by root x. Since x can be written as what? Root x into root x. When root x and root x cancel, we will get what? 1 by root x. So here these two terms we can cancel and write root 2x plus 7 on the denominator. So this will be equal to 1 by root of 2x plus 7 into root of 4 minus x square. Then this minus becomes plus because we take minus common. Okay, and cos inverse x by 2 divided by root of 2x plus 7 into 2x plus 7. That means root x raised to 1 by 2 into x raised to 1, and it is x raised to 3 by 2. Clear? So here we can combine these two, 2x plus 7 the whole raised to 3 by 2. Root 2x plus 7 is 2x plus 7 the whole raised to 1 by 2 and 2x plus 7 the whole raised to 1. That is a raised to m into a raised to n, that will be equal to a raised to m plus n. That is 1 by 2 plus 1, which is equal to what? 3 by 2. So 2x plus 7 the whole raised to 3 by 2. That means dy by dx is equal to minus of 1 by root of 2x plus 7 into root of 4 minus x square, then plus cos inverse x by 2 divided by 2x plus 7 the whole raised to 3 by 2, and that will be the final answer. Understood? Now we move on to question number 6. It's a very important question. I think you are familiar with this question. We have already discussed the same question in chapter number 2, inverse trigonometric functions. Okay, come to the question. Differentiate cot inverse root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x, and the condition is 0 less than x less than pi by 2. Okay. So let it be y. Let y is equal to cot inverse root of 1 plus sin x then plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. And what we have to do is we have to multiply both numerator and denominator with the conjugate of the denominator. You all know the conjugate. We have to change the sign in the middle. That means here it is minus, so we have to change the sign as plus and multiply both numerator and denominator by that particular term. Okay. That is cot inverse root 1 plus sin x plus root 1 minus sin x into the conjugate of the denominator, that is root 1 plus sin x plus, here it is minus, so plus, we have to change the sign, root of 1 minus sin x whole divided by, here also the same process, root 1 plus sin x minus root 1 minus sin x, then into root 1 plus sin x then plus root 1 minus sin x. Okay. So which is equal to cot inverse. Look at this numerator, root 1 plus sin x plus root 1 minus sin x. If we take the first term as a and this one as b, it will be a plus b. Okay. Again the same term repeats, root 1 plus sin x, that is a, here 1 minus sin x, root 1 minus sin x, and it is b. That is a plus b, a plus b. A plus b into a plus b is what? A plus b the whole square. Okay. And we know a plus b the whole square is, the expansion is what? A square plus 2ab plus b square. That I am going to apply here. So a square means root 1 plus sin x the whole square. Then plus 2ab, 2 into root 1 plus sin x into root 1 minus sin x. Then plus b square, that is root 1 minus sin x the whole square, whole divided by, and in the denominator root 1 plus sin x minus root 1 minus sin x, that is a minus b. Here root 1 plus sin x plus root 1 minus sin x, that is a plus b. Once again, a minus b into a plus b. What is a minus b into a plus b? It's nothing but a square minus b square. You all know a square minus b square is equal to what? A plus b into a minus b. So here we can write root 1 plus sin x the whole square, that is a square minus b square, that is 1 minus root of 1 minus sin x the whole square. Clear? So which is equal to cot inverse, here root of 1 plus sin x the whole square, and it is 1 plus sin x, then plus 2 into root a into root b. Okay, root a into root b is what? Root ab. So root of 1 plus sin x into 1 minus sin x. We can combine and write it in a single root. Then plus, here root of 1 minus sin x the whole square, and it is 1 minus sin x, whole divided by a square minus b square. Here root 1 plus sin x the whole square, and it is 1 plus sin x, then minus of root 1 minus sin x the whole square, and it is 1 minus sin x. Okay. In the numerator we can cancel sin x and minus sin x. So y is equal to cot inverse, here the first term is 1, here also 1, 1 plus 1 and it is 2, 2 plus, and the next term is 2 into root of, there is 2 into root of, inside the root the term is 1 plus sin x into 1 minus sin x, 1 plus sin x into 1 minus sin x, a plus b into a minus b, again the identity a square minus b square. 1 square minus 1 square is 1. 1 square minus sin square x. Okay, divided by, here we can open the bracket, that is 1 plus sin x minus 1 minus of minus plus sin x. So this 1 and minus 1 we can cancel, which is equal to cot inverse 2 plus 2 into root of 1 minus sin square x is cos square x. You have identity, trigonometric identity, 1 minus sin square x is equal to cos square x, and sin x plus sin x is 2 sin x. So which is equal to cot inverse 2 plus 2 root of cos square x, and it is cos x divided by 2 sin x. So from the numerator we can take on 2 common. So 2 into 1 plus cos x divided by 2 sin x. This 2 we can cancel, that is cot inverse 1 plus cos x. 1 plus cos x, again we have trigonometric formula. 1 plus cos x is what? 2 cos square x by 2. There are two important formulas. 1 plus cos x is 2 cos square x by 2, and 1 minus cos x is what? 2 sin square x by 2. Okay, that are the two frequently used formulas. We have to remember that. 1 plus cos x is 2 cos square x by 2. And in the denominator, sin x. Sin x, again we have formula. Sin 2x is 2 sin x cos x, and in the submultiple angle we have formula 2 sin x by 2 cos x by 2. So 2 sin x by 2 cos x by 2. Here we can cancel 2 and 2, then 1 cos x by 2, and here 1 cos x by 2. Okay, so the remaining is cot inverse cos x by 2 divided by sin x by 2. That is cot inverse cos by sin. Cos by sin is what? It's cot. Okay, cos theta by sin theta is cot theta. So here cot x by 2. So cot inverse cot x by 2, and cot inverse cot x by 2 is x by 2. Cot inverse cot theta, reverse operation. Okay, sin inverse sin theta is equal to theta, cos inverse cos theta is equal to theta. Similarly, cot inverse cot theta is equal to theta. So here in the angle the term is x by 2. So cot inverse cot x by 2 is what? X by 2. Now we got y is equal to x by 2. Y is equal to x by 2. Our intention is to find the derivative of this term. So that we first simplify the question as what? X by 2. Actually the question was cot inverse root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. So that question we simplified in the form x by 2. Y is equal to x by 2. Now we can easily find the derivative differentiating with respect to x. Dy by dx is equal to derivative of x is 1, that is 1 by 2. Okay, here from the beginning to this much step you have already proved in the second chapter inverse trigonometric function, and the additional is this much portion only. Okay, y is equal to x by 2, and we differentiate with respect to x, and we got dy by dx as what? 1 by 2. Clear? Now we move on to the next question. Log x the whole raised to log x. It's in power form, that is the function is of the form u raised to v. Okay, so y is equal to log x the whole raised to log x with x greater than 1. We can take logarithm on both sides, taking log on both sides. So log y is equal to log x raised to log x. We can apply the logarithmic formula. Log a raised to b is equal to b log a. So it becomes log x into log x. That is, we got log y is equal to log x into log x. Now we can find the derivative differentiating with respect to x. Derivative of log y is 1 by y into dy by dx, and here product rule, first function log x into derivative of log x, that is 1 by log x into derivative of log x, it is 1 by x, then plus the second function, that is log x into derivative of first function, derivative of log x is 1 by x. Okay, that is dy by dx is equal to, here we can multiply this y on right side, y into this log x we can cancel, and the remaining is 1 by x plus log x whole divided by x. So dy by dx is equal to y, the value of y is log x raised to log x, so log x raised to log x into, here the denominator is same, so you can combine the two terms keeping the denominator same, that is 1 plus log x whole divided by x. That means the derivative dy by dx is equal to log x raised to log x into 1 plus log x divided by x. Clear? Now the next question is cos of a cos x plus b sin x for some constant a and b. It's a simple question. So let it be y is equal to cos of a cos x plus b sin x. You can find the derivative directly, dy by dx is equal to cos of a cos x plus b sin x. So first of all, this can be treated as x. So the question becomes cos x. What is the derivative of cos x? It's nothing but minus sin x. So we can write minus sin of a cos x plus b sin x. Clear? And we have to apply the chain rule. There is d by dx of, here instead of x the term is a cos x plus b sin x. That is d by dx of a cos x plus b sin x. So which is equal to minus sin of a cos x plus b sin x. Then derivative of this one, a cos x, that is a into minus sin x, then b into sin x derivative cos x, that is minus sin of a cos x plus b sin x, then minus a sin x plus b cos x. Okay. dy by dx is equal to minus sin a cos x plus b sin x into minus a sin x plus b cos x. Clear? Now we move on to question number 9. Sin x minus cos x the whole raised to sin x minus cos x, pi by 4 less than x less than 3 pi by 4. Let y is equal to sin x minus cos x the whole raised to sin x minus cos x. Here also the question is of the form a function to the power another function. That means y is equal to u raised to v, where u and v are functions of x. So we have to take logarithm on both sides in order to find the derivative. So taking log on both sides. So log y is equal to log sin x minus cos x the whole raised to sin x minus cos x. So which is equal to log a raised to b log a, that is sin x minus cos x into log of sin x minus cos x. Okay. Now we can differentiating with respect to x. 1 by y into dy by dx is equal to, here product rule, sin x minus cos x into, that is first function into derivative of second function, derivative of log sin x minus cos x. Log x is 1 by x, so here 1 by sin x minus cos x into derivative of sin x minus cos x, because instead of x the term is sin x minus cos x, so we have to apply the chain rule into sin x derivative cos x, then minus cos x derivative minus sin x, that is plus sin x, minus of minus plus. Okay, then plus second function into, that is log of sin x minus cos x into derivative of first function, derivative of sin x minus cos x, that is derivative of sin x is cos x, then minus derivative of cos x, it is minus sin x, again minus of minus plus sin x. Okay, here we can cancel sin x minus cos x and sin x minus cos x. So we can write dy by dx is equal to this y into, here the remaining term is cos x plus sin x, then plus log sin x minus cos x into cos x plus sin x. Okay. So here in both terms cos x plus sin x is common. Here on cos x plus sin x and the second term also on cos x plus sin x, that we can take it out. And the y value is what? Sin x minus cos x the whole raised to sin x minus cos x, that we can replace. So dy by dx is equal to, first of all we can write the y value, that is sin x minus cos x the whole raised to sin x minus cos x, and the common term is what? Cos x plus sin x, that we can write cos x plus sin x, then into, within bracket we can write the remaining terms. Here we take cos x plus sin x out, so the remaining is what? 1. So 1 plus, here also this term cos x plus sin x we take it out, so the remaining is log sin x minus cos x. So 1 plus log sin x minus cos x. Okay, so the final answer dy by dx is equal to sin x minus cos x the whole raised to sin x minus cos x into cos x plus sin x into 1 plus log of sin x minus cos x. Understood? Now the next question is x raised to x plus x raised to a plus a raised to x plus a raised to a for some fixed a greater than 0 and x greater than 0. Here first term is x raised to x, so that we can take it as u. Let u is equal to x raised to x, and taking log on both sides we get log u is equal to log x raised to x. Clear? That can be written as x log x. Can differentiate with respect to x. 1 by u into du by dx is equal to, here product rule, x into 1 by x plus log x into 1. X and x cancel, we get 1 plus log x. That is du by dx is equal to what? U into 1 plus log x. U value is x raised to x, that is x raised to x into 1 plus log x. Okay, that can be taken as equation number 1. Clear? Now we can take the question completely. Let y is equal to x raised to x plus x raised to a plus a raised to x plus a raised to a. Now we can differentiate with respect to x. Derivative of y is dy by dx, and derivative of x raised to x, that we find it as x raised to x into 1 plus log x. So we can replace x raised to x into 1 plus log x. And in the second term it is x raised to a. Here we can apply the formula x raised to n. What's x raised to n? Derivative of x raised to n? N x raised to n minus 1. But instead of n the number is a. So we can write a x raised to a minus 1. N x raised to n minus 1. Okay. So a x raised to a minus 1, then plus, and the third term is a raised to x. A raised to x also we have direct formula. Derivative of a raised to x is what? A raised to x into log a. Okay, that you already learned. Derivative of a raised to x is a raised to x log a. Then plus, last term is a raised to a. Here a is a constant. So a raised to a is also a constant, again a constant, and the derivative of a constant is what? 0. So the derivative of the last term a raised to a will be 0. So which is equal to x raised to x into 1 plus log x, then plus a x raised to a minus 1, then plus a raised to x into log a. Okay, that means dy by dx is equal to x raised to x into 1 plus log x plus a into x raised to a minus 1, then plus a raised to x into log a. Clear? Now the 11th question is x raised to x square minus 3 plus x minus 3 the whole raised to x square for x greater than 3. Okay, so let it be y, that y is equal to x raised to x square minus 3 then plus x minus 3 the whole raised to x square. So which can be written as u plus v, y is equal to u plus v, where u is equal to the first term x raised to x square minus 3 and v is equal to x minus 3 the whole raised to x square. Clear? Now we can find the derivative. Dy by dx is equal to du by dx plus dv by dx. Take it as equation number 1. Now we can take the first term, that is u. Let u is equal to x raised to x square minus 3. And we can apply the logarithmic differentiation. So taking log on both sides, log u is equal to log x raised to x square minus 3. That is log u is equal to, you can use the power rule, log a raised to b log a, x square minus 3 into log x. Now we can differentiate with respect to x. So 1 by u into du by dx, which is equal to, here product rule, x square minus 3 into derivative of log x, it is 1 by x, then plus log x into derivative of x square minus 3, derivative of x square is 2x and derivative of 3 is 0. So the final answer is 2x. So du by dx is equal to u into x square minus 3 divided by x, then plus 2x log x. Okay, now we can replace the value of u, and u is x raised to x square minus 3. So x raised to x square minus 3 into x square minus 3 divided by x, then plus 2x log x. Take it as equation number 2. So du by dx is equal to x raised to x square minus 3 into x square minus 3 divided by x, then plus 2x into log x. Okay. Now we can take the second term, that is v. So let v is equal to x minus 3 the whole raised to x square. And here also we can take the logarithm, log v is equal to log of x minus 3 the whole raised to x square. That is x square into log x minus 3. We can differentiate again with respect to x. That is 1 by v into dv by dx is equal to x square into 1 by x minus 3, then plus log x minus 3 into x square derivative 2x. So here the first function is x square, log x derivative 1 by x. Here instead of x the term is x minus 3, so 1 by x minus 3 into derivative of x minus 3, but it is 1, so the answer is 1 by x minus 3. Okay. Then second function log x minus 3 into derivative of first, derivative of x square is what? 2x. So dv by dx is equal to, this v we can cross multiply, v into x square by x minus 3, then plus this 2x I write first, 2x into log x minus 3. Now we can replace the value of v, and it is x minus 3 the whole raised to x square into x square by x minus 3, then plus 2x into log x minus 3. Take it as equation number 3. Okay. Now we got du by dx and dv by dx, and in order to find dy by dx, we can replace these two values in equation 1. In equation 1 it is dy by dx is equal to du by dx plus dv by dx. Clear? So equation 1 implies dy by dx is equal to, first du by dx, that is x raised to x square minus 3 into x square minus 3 divided by x, then plus 2x log x. Okay, then plus dv by dx, it's x minus 3 the whole raised to x square into x square by x minus 3, then plus 2x into log x minus 3. Okay, that is the final answer. dy by dx is equal to du by dx plus dv by dx, that is x raised to x square minus 3 into x square minus 3 divided by x, then plus 2x log x plus dv by dx, that is x minus 3 the whole raised to x square into x square by x minus 3, then plus 2x into log x minus 3. Clear? And now we move on to next question. Question number 12. Find dy by dx if y is equal to 12 into 1 minus cos t and x equal to 10 into t minus sin t, where minus pi by 2 less than t less than pi by 2. Okay. So here the question is in parametric form. So we have to find dy by dt and dx by dt separately. Okay. So given y is equal to 12 into 1 minus cos t. From this we can find dy by dt. That means the derivative of y with respect to t. 12 into derivative of 1 is 0, then minus derivative of cos t. It's minus sin t and minus of minus is plus. Okay. So which is equal to 12 sin t. That is dy by dt is 12 sin t. And also given x is equal to 10 into t minus sin t, and we can find dx by dt as dx by dt is equal to 10 into derivative of t, it's 1, then minus derivative of sin t and it is cos t. Okay, that is dx by dt is equal to 10 into 1 minus cos t. Now we can find dy by dx. We have formula dy by dt divided by what? Dx by dt. You can replace the values. Dy by dt is 12 sin t. So 12 sin t divided by, and dx by dt is 10 into 1 minus cos t. So 10 into 1 minus cos t. So which is equal to 12 into sin t. Sin t we have formula 2 sin t by 2 cos t by 2 divided by 10 into 1 minus cos t. So 10 into 1 minus cos t, 2 sin square t by 2. Trigonometric formula 2 sin square t by 2. So this 2 and 2 we can cancel, and on sin t by 2, here also on sin t by 2 we can cancel. This 12 and 10 you can cancel by 2. 6 2s are 12 and 5 2s are 10. So it becomes 6 cos t by 2 divided by 5 sin t by 2, or we can write 6 by 5 separately, and the remaining is what? Cos t by 2 divided by sin t by 2, and it is cot t by 2. Okay, that is dy by dx is equal to 6 by 5 into cot t by 2. Understood? So that's all for today. We shall discuss the remaining questions in the upcoming videos. If you have any doubts, you can ask me in the comment section. So thanks for watching. Thank you.